Good afternoon. Slight change of topic. So I'll talk about chips. So my name is Asgar, and my research team here at NYU Abu Dhabi and I, we strongly believe that our recent research can be turned into a successful business. And in particular, we'll talk about TrustChip, a software tool that enables chip designers to produce chips that are resilient to piracy and tampering. So piracy and tampering in general are big problems, and electronic chips are no exception. The underlying reason in the case of chips is that these chips are designed in one place by the chip designers, a safe place, but then when the fabrication time comes, they're sent out to a foundry that is in another country, a different company obviously, and another continent even. So because of this model, there are concerns that are mostly have to do with piracy, tampering, and counterfeiting. And every year, billions of dollars are lost in chip industry because of these problems. The problem is none of the chips out there have built-in defenses, and they're all vulnerable to these problems. If you're a chip designer, what you do is you use a bunch of software tools to create this chip map that is ready for fabrication. It takes months, of course. And this chip map has all your IP, hardware IP information, and this is what's needed for fabricating your chips. So you send this off to a third-party vendor, a fab, and by using this information, they fabricate your chips. The problem is, as a chip designer, you have no control over this process. So the chips that come out of this fabrication could have malicious circuitry inserted into them. We call them hardware trojans. Or they could actually take a closer look at this design to pirate or clone your IP because everything is out in the open. Our solution is a software tool that the chip designers will be using to integrate locks to the design at the hardware level. So once this chip design is sent to the fabs, the chips that will come out of the fabrication will be locked chips that could only be unlocked by loading a secret key on the memory of the chip. And this secret key obviously is the knowledge of the designers. So designers have control over the process because of this technology. And these locks would be there to shield your design IP from piracy, because without the knowledge of the secret key, whoever tries to reverse engineer your design will not make any sense of the functionality of your chip. Our advantage as a team, as a research team, is that we have the state-of-the-art solution. We can guarantee theoretically provable security levels. Whatever I'm saying right now has already been peer-reviewed and validated academically. We have patents protecting our IP solution. And we took a microprocessor design from a company called ARM. We applied our software to it, and we created a secure version of their chip. And we now have a chip prototype as of 2 months ago that presents a working solution. So we can look at the market from a software and a hardware point of view. If you look at the software side, there are these gigantic companies, billions of dollars worth companies, who are providing software tools to chip designers. The three companies are Synopsys, Mentor, and Cadence. They dominate the market, and it's worth billions of dollars. And if you look at the hardware side of the market, we have the chip industry worth hundreds of billions of dollars. And if you focus on only one sector, which is defense, where these solutions make the most sense, and they're really concerned about these problems, it's still worth billions of dollars. So this model gives a variety of business options to us to explore. We could actually partner with one of those software companies, integrate our solution into their platform, and then we could use their customer database to reach out to a lot of these chip designers through their platform. That's one option. Another option would be for us to deal with chip designers directly, license our software tool to them, and then charge them on a per manufactured chip basis. This is the current market situation. So one of these three software vendor companies, Mentor Graphics, very recently, a couple of months ago, introduced their solution that promises the same things that I'm promising. This happened very recently. Their solution is a few years behind our solution. But you can see that the interest is there, and the other competitors, Cadence and Synopsys, we don't know whether they're going to enter the market with their own solution. But the time is now. The topic is really hot. So this is my research team. We have years of research and practical experience. We have papers. We have patents. You can look us up on the internet. Academically, we already raised funding to support our research through agencies such as U.S. Department of Defense, U.S. National Science Foundation, and various chip design companies. But what we're trying to do is turn this academic research into successful business. And if you have any questions, you can talk to me now, or you can drop an email. I'll be happy to talk. Thank you.
So going back to your kind of 3 options for the business, do you guys have a preference for which path you want to take over the next 6 months, year?
They have all pros and cons. The first option would be the smoothest integration and the easiest way to reach a big domain of customers, because this software company, say Synopsys, they already have their customer database. Chip designers are already used to using their software tools, so that it's already implemented in their infrastructure. So if we can integrate our solution into this platform, it will be really easy to deploy, and they'll be easily adoptable. But I think the other option, option number 3, may be a better option from a financial standpoint. It may be more difficult because we'd have to make sure that our solution will be integrated into the customer's platform. So pros and cons. I guess we'll start trying option number 1 first and see whether they're interested in competing with Mentor Graphics, their big competitor, by using our solution. And then we'll explore other options.
Okay, this is currently a research project here at the university, so how much more work is still needed for the actual commercial product?
So the fact that we have a chip prototype already gives us confidence that we have a working solution. But again, it's a research project, so the software has been implemented in a way that it's quick and dirty, gets the job done. For the users out there to be able to use our software, it needs to be packaged properly. The user interface should be properly set up. It's just a few months of work, 2-3 months of work, and then it'll be ready to go. Big hand.